So let us do all important SAQs from Maths 2A. So the first question is, show that 2 minus I by 1 minus 2I whole square and minus 2 minus 11I by 25 are conjugate to each other. So let us take Z1 is equal to the first complex number and Z2 is equal to the second complex number. Now we'll take Z1, we will solve it and we will see that we are getting conjugate of Z2. So that is 2 minus I by, open the brackets in the denominator, A minus B whole square. So A square plus B square minus 2AB. That is 2 minus I by 1 minus 4 minus 4I. Why I wrote minus 4 here? Because I square is minus 1. That is 2 minus I by minus 3 minus 4I. Now the denominator is in the form A plus IB. So we have to rationalize it. So if you rationalize, you will get 2 minus I by minus 3 minus 4I. We are rationalizing the denominator. So in the denominator, you have minus 4I. So we multiply and divide with minus 3 plus 4I. Now if you multiply this, two brackets, like how to multiply this into this into this, this into this, this into this. So 2 into minus 3 is minus 6 plus 8I plus 3I minus 4I square. By denominator is in the form A minus B into A plus B. So that is A square minus B square. Now that is minus 6. What is 8I plus 3I? It is 11I. Then what is I square? I square is minus 1. So minus 4I square will become plus 4. By 9 minus 16I square is minus 16. So minus into minus will become plus 16. Now that is minus 2 plus 11I by 25. Can you see? This complex number and Z2 both are conjugate to each other. They differ only with a plus or minus sign. So this is nothing but Z2 conjugate. Therefore, Z1 and Z2 are conjugate to each other. Conclusion is very important. This last step you have to write. Now take the next question. This question is from quadratic expressions. Determine the range of the following expression. So one range problem is 100% sure. So let us take how to solve this question. Let y is equal to x square plus x plus 1 by x square minus x plus 1. Now you cross multiply. So you get yx square minus yx plus y is equal to x square plus x plus 1. Take all the right hand side terms to the left hand side. So you get yx square minus yx plus y minus x square minus x minus 1 is 0. Now from x square terms, we will get y minus 1 into x square. And if you take x terms common, we get minus of y plus 1 into x plus non-x terms we write separately, that is y minus 1 equals to 0. Now from this equation, we will get ABC values. A is the coefficient of x square. So A is y minus 1, B is minus of y plus 1, C is y minus 1. Now since x belongs to R, discriminant is greater than or equal to 0. So what is the discriminant? B square minus 4AC is greater than or equal to 0. Now let us substitute the values. Minus of y plus 1 whole square minus 4 into y minus 1 into y minus 1 greater than or equal to 0. So that is y plus 1 whole square minus 4 into y minus 1 whole square greater than or equal to 0. Now what is y plus 1 whole square? We apply a plus b whole square formula. A square plus b square plus 2ab minus 4 if we take outside. Now again y minus 1 whole square is y square plus 1 minus 2y greater than or equal to 0. Now we open the brackets. Y square plus 1 plus 2y minus 4y square minus 4 plus 8y greater than or equal to 0. So y square minus 4y square is minus 3y square plus 10y minus 3 greater than or equal to 0. Whenever highest power has a negative coefficient, we take minus common. So if you take minus common, you get 3y square minus 10y plus 3. Whenever we take minus common, inequality changes. Less than or equal to 0. Now you split the middle term. So 3y square minus 9y minus y plus 3 less than or equal to 0. So if we take 3y common, we will get y minus 3. If you take minus 1 common, y minus 3 less than or equal to 0. Again, if we take y minus 3 common, you will get 3y minus 1 less than or equal to 0. So y values are 3 and 1 by 3. Now, whenever you have less than or equal to symbol, then range is simply you can put it within the square bracket. Square brackets means closed interval. That means the corners are included. So whenever you have less than or equal to symbol, that means all the values of the expression lie between 1 by 3 and plus 3. Understood? Take the next question. Even this is very important. It is from permutation and combination. The question is, find the sum of all 4-digit numbers that can be formed using the digits 1, 3, 5, 7, 9. So you have to make 4-digit numbers using 5 digits. So how many such numbers can you make? Number of 4-digit numbers formed using the digits 1, 3, 5, 7, 9 without repetition is NPR. Formula is NPR. N is 5, R is 4. Altogether there are 5 digits. So N is 5. We need to make 4-digit numbers. So R is 4. So what is 5p4? Start from 5, reduce 4 times. 5 into 4 into 3 into 2. That is 120. Now, out of these 120 numbers, how many numbers contain 1 in units place? So there is a 4-digit number. We want 1 in the units place. So how many such numbers you can get? Now here the digits are 4 and the places are 3. So you can get 4p3 numbers. Okay. Now the same way 4p3 numbers contain 1 in tens place. That is like this. Then 4p3 numbers contain 1 in hundreds place. This way. Then 4p3 numbers contain 1 in thousands place. This way. Okay. So what is the value obtained? Value obtained by adding 1 in all the numbers. That is 4p3 into 1 into 1 in units place. plus 4p3 into the number is 1 and the place value is 10 plus 4p3 into 1 into 100 plus 4p3 into 1 into 1000. Now the same way, so let us solve that. If we take 4p3 into 1 common, we will get 1 plus 10 plus 100 plus 1000. So that is 4p3 into 1 into 1111. The same way, what is the value obtained by adding 3 in all numbers? That is 4p3 into 3 into 1111. The same way, value obtained by adding 5 in all numbers is 4p3 into 5 into 1111. The same way, value obtained by adding 7 in all numbers is 4p3 into 7 into 1111. The same way, value obtained by adding 9 in all numbers is 4p3 into 9 into 1111. Now, what is the sum of all the numbers? Sum of all the numbers is we need to add all of them. 4p3 into 1 into 1111 plus 4p3 into 3 into 1111 plus 4p3 into 5 into 1111 plus 4p3 into 7 into 1111 plus 4p3 into 9 into 1111. How can I further simplify? If I take 4p3 into 1111 common, we will get 1 plus 3 plus 5 plus 7 plus 9. Now what is 4p3? Start from 4, reduce 3 times into 1111 into what if I add these numbers? It is 25. 4 into 3 into 2 is 24. 24 into 1111 into 25. So if you multiply these three numbers, you will get 6,66,600. Now take the next question. Find the number of ways of selecting a cricket team of 11 players from 7 batsmen and 6 bowlers such that there will be at least 5 bowlers in the team. So how many players are there in the team? Total number of players in the team is 11. Let us make a table. How many batsmen are there? 7 batsmen are there. How many bowlers are there? There are 6 bowlers. So what combinations will you get? We will see. Before the combinations, we will take the number of players in the team. You need 11 players in the team. So what are the combinations you get? Let's see that. And how many types you get, that also we will see. So there are 2 types we get. The condition is at least 5 bowlers. At least means minimum. So either you can take 5 bowlers or 6 bowlers. Because maximum you have 6 bowlers. So you cannot take beyond that. And if you are taking 5 bowlers, how many batsmen should we take? We should take 6 batsmen because we need to make a team of 11 players. And if you are taking 6 bowlers, we need to take 5 batsmen because we need to make a team of 11. Now from 7 batsmen, we have to select 6 batsmen. Whenever selection comes into picture, we take combinations. So from 7 batsmen, you are selecting 6 batsmen. And from 6 bowlers, you are selecting 5 bowlers. Now 7C6 can be written as 7C1 also. And 6C5 can be written as 6C1. How can I write this? Because NCR is NC n minus R. Using this formula, we can write 7C6 as 7C, 7 minus 6, that is 1. So 7C1 is 7 and 6C1 is 6. That is 42. So type 1 can be done in 42 ways. Now coming to the second type, from 7 batsmen you can select 5 batsmen, and from 6 bowlers you can select 6 bowlers. So that is 7C2 into 6C0. Now how to simplify 7C2? Start from 7, reduce 2 times by 2 factorial, and 6C0 is 1. 2 ones are 2 threes are, that is 21 ways. Therefore, total number of ways is 42 plus 21, that is 63. Take the next question. Resolve 5x plus 6 by 2 plus x into 1 minus x into partial fractions. So let us take 5x plus 6 by 2 plus x into 1 minus x. As you can see, the denominators are both linear factors. So we can write this as a by 2 plus x plus b by 1 minus x. Now you take LCM. So we will get 5x plus 6 equals a into 1 minus x plus b into 2 plus x. Now first I want to make this 1 minus x 0. So I put x is equal to 1. So 5 into 1 plus 6 is equal to b into 2 plus 1. So 5 plus 6 is 11 equals 3b. So b equals 11 by 3. After getting b value, we put x equals to minus 2 to make the second bracket as 0. So 5 into minus 2 plus 6 equals to a into 1 minus of minus 2 will become plus 2. 5 into minus 2 is minus 10 plus 6 is 3a. So minus 4 equals 3a, and so a is minus 4 by 3. Now let us substitute a and b values in this equation. Let us mark the first step as first equation. So substituting in 1. So you will get 5x plus 6 by 2 plus x into 1 minus x equals to, what is the a value we got? Minus 4 by 3. Minus 4 by 3 by 2 plus x plus 11 by 3 by 1 minus x. You can even simplify this way. Minus 4 by 3 into 2 plus x plus 11 by 3 into 1 minus x. This is how you resolve into partial fractions. Take the next question. This is also very important. It is from probability. If A and B are two events with P of A union B equals to 0.65 and P of A intersection B is 0.15, then find the value of P of A complement plus P of B complement. So first let us write what is given to us. Given P of A union B equals to 0.65 and P of A intersection B is equal to 0.15. We use addition theorem here. So by addition theorem of probability, what is the addition theorem of probability? P of A union B equals P of A plus P of B minus P of A intersection B. So in the place of P of A union B, we write 0.65 equals to P of A and P of B is not known to us, minus 0.15. Take minus to the left hand side. So you get 0.65 plus 0.15 is P of A plus P of B. So from here we get P of A plus P of B equals to 0.8. Let us mark this as equation number 1. Now they are asking us to find P of A complement plus P of B complement. What is P of A complement? It can also be written as 1 minus P of A plus P of B complement is 1 minus P of B. 1 plus 1 makes 2, and from these two terms, if we take minus common, we get P of A plus P of B. Now from equation number 1, we got P of A plus P of B is 0.8. So 2 minus 0.8 is 1.2. This is the final answer. Take the next question. A problem in calculus is given to two students A and B, whose chances of solving it are 1 by 3 and 1 by 4 respectively. Find the probability of the problem being solved if both of them try independently. So let us say A be the event that the problem is solved by A. So that implies P of A is 1 by 3. Let B be the event that the problem is solved by B. So P of B is 1 by 4. Now what is the probability of the problem being solved? When can you say that a problem is solved? If either A solves it or B solves it. So that is P of A union B. P of A union B is P of A plus P of B minus P of A intersection B. This is by addition theorem. But as you can see, A and B are two students. So these are two independent events. So you can write it as P of A plus P of B minus P of A into P of B. Because whenever events are independent, we can write P of A intersection B as P of A into P of B. So that is P of A is 1 by 3 plus 1 by 4 minus 1 by 3 into 1 by 4. That is 1 by 3 plus 1 by 4 minus 1 by 12. If you take the LCM, you get 3 plus 4 minus 1 by 12. That is 6 by 12, which is equal to 1 by 2. 1 by 2 is the final answer. Take the next question. It is from complex numbers. Very, very important. If x plus iy equals to 1 by 1 plus cos theta plus I sin theta, then show that 4x square minus 1 equals to 0. First, let us write what is given to us. Given x plus iy equals 1 by 1 plus cos theta plus I sin theta. Now we rationalize the denominator. So how to rationalize? 1 by 1 plus cos theta is the real part plus I sin theta is the imaginary part. So we multiply and divide with 1 plus cos theta minus I sin theta by 1 plus cos theta minus I sin theta. Now numerator is 1 plus cos theta minus I sin theta by denominator is a plus b into a minus b. So that is 1 plus cos theta whole square minus I square sin square theta. So that is 1 plus cos theta minus I sin theta by, if you expand 1 plus cos theta whole square, you will get 1 plus cos square theta plus 2 cos theta minus I sin theta minus I square sin square theta, that is plus sin square theta, because I square is minus 1. Now you can see sin square theta plus cos square theta is 1. 1 plus 1 is 2. So numerator I am not changing. I write as it is. Denominator we can write 2 plus 2 cos theta. That is 1 plus cos theta minus I sin theta by, if we take 2 common, we get 1 plus cos theta. Now if we separate real and imaginary parts, 1 plus cos theta by 2 into 1 plus cos theta plus I into minus sin theta by 2 into 1 plus cos theta. On the left hand side, you have x plus iy. Now comparing real and imaginary parts. Comparing real and imaginary parts. So we get, now here a 1 plus cos theta, 1 plus cos theta gets cancelled. So x is 1 by 2 and y is minus sin theta by 2 into 1 plus cos theta. Now what is LHS? LHS is 4x square minus 1. That is 4 into 1 by 2 whole square minus 1. That is 4 into 1 by 4 minus 1. 4 cancel, 1 minus 1 is 0. That is RHS. Finally, we conclude, therefore, LHS equals to RHS. Take the next question. It is from quadratic expressions. If the expression x minus p by x square minus 3x plus 2 takes all real values for x belongs to R, then find the bounds for p. So again we proceed the same way. Let y equals x minus p by x square minus 3x plus 2. We cross multiply, so we get yx square minus 3yx plus 2y is equal to x minus p. Now take all right hand side terms to left hand side. So we get yx square minus 3yx plus 2y minus x plus p is 0. Now we separate x square terms, x terms and constants. So y into x square. From these two terms, if we take minus common and also if we take x common, we get this term. Then 2y plus p equals to 0. Now here, since x is real, you can say discriminant is greater than or equal to 0. Discriminant is b square minus 4ac is greater than or equal to 0. Now in the place of a you have y. In the place of b you have minus of 3y plus 1. In the place of c you have 2y plus p. Now we are applying b square minus 4ac. So b square is 3y plus 1 whole square minus 4 into y into 2y plus p greater than or equal to 0. Now expand this. 9y square plus 1 plus 6y minus 8y square minus 4py greater than or equal to 0. Now 9y square minus 8y square is y square. If I take y common, we get 6 minus 4p into y plus 1. It is greater than or equal to 0. Now this is a quadratic equation expression in terms of y. So y is real. Then again b square minus 4ac is greater than or equal to 0. Here what is b? B is 6 minus 4p whole square minus 4 into a is 1 and c is also 1. So if you open the brackets, you get 36 plus 16p square minus 48p minus 4 greater than or equal to 0. So you get 16p square minus 48p plus 32 greater than or equal to 0. Here if we take 16 common, we will get p square minus 3p plus 2 greater than or equal to 0. Here you can see after getting this step, like this step in terms of P, you can see based on the values of P, the roots can be real or imaginary. The roots can be real or imaginary. So that's why we have to take less than or equal to 0 here. Less than or equal to 0. Because P is unknown. We don't know what is P. So this is less than or equal to 0. Now split the middle term. Minus 2P minus P plus 2 is less than or equal to 0. So P common, P minus 2. Minus 1 common, P minus 2. So P minus 2 into P minus 1. Less than or equal to 0. So P is equal to 1 or P is equal to 2. So now if you see the question, in the question, denominator is x square minus 3x plus 2. So if it is exactly equal to 1 and 2, it will be not defined. Okay, so if p is equal to 1 or p is equal to 2, then x minus p by x square minus 3x plus 2 is not defined. Because if you split the factors in the denominator, you will get x minus 1 into x minus 2. If you put x as 1 or 2, it will become 0. Denominator will become 0. Therefore, what are the bounds? Bounds are all the p values lie between 1 and 2, excluding 1 and 2. So here in this step, you can see you have to just try x is real. So directly you can write the roots can be real or imaginary. Then b square minus 4ac is less than or equal to 0. Take the next question. This is the most probable question. If the letters of the word master are permuted in all possible ways and the words thus formed are arranged in a dictionary order, then find the rank of the word master. So first let us write the alphabetical order of the word master. Is A, E, M, R, S, T. So first number of words begin with A. That is, now see it is a 6-letter word, right? So if we fix A in the first position, the remaining 5 letters are there. 5 letters and 5 places. You can fill the 5 places using these 5 letters in 5 factorial ways. That is 120. Now number of words begin with after A you have E. So you get all the words starting with E. So that also can be done in 5 factorial ways. That is 120. Now number of words begin with M. M is our requirement. So once the requirement is filled, we fix this letter M over here and we go to the next letter, the next place. Whenever you go to the next place, start from the beginning. So we have to fix A here now. A is also a requirement. So go to the next letter. After going to the next position, you have to again start from the beginning. A is already fixed. So the next letter is E. But E is not our requirement. So stop here and you write M-A-E here. And this can be done in 3 factorial ways. 3 factorial is 6. Now number of words begin with. Now MA you have already fixed. E is not our requirement. So after E, you get M, but M is already fixed. So we get R. So number of words starting with R is also 3 factorial, that is 6. Now number of words begin with M. A is already fixed. Now after R you have S. S is our requirement. So go to the next position. Again start from the beginning. So A is already fixed here. We take E. So number of words begin with MASE is 2 factorial. 2 factorial is 2. Now number of words begin with, now MAS is already fixed. Now after E, you have M, which is already fixed. Then you have R. So that is MASR. That is also 2 factorial, which is equal to 2. Now number of words beginning with MAS is already fixed. After R, you have S. S is already fixed. After S, you have T. Now T is our requirement, so we are fixing T here. Go to the next position. When you go to the next position, you have to start from the beginning. So the first letter is A, which is already fixed. Now the next letter is E. Now E is our requirement, so fix E here. Go to the next position. And the only left letter is R. So fix R over here. So in how many ways can you do this? Now no letter is left over, so that is 0 factorial. But we know that 0 factorial is 1. So what is rank of the word? Therefore, rank of the word master is 120 plus 120 plus 6 plus 6 plus 2 plus 2 plus 1. That is 257. So rank of the word master is 257. Take the next question. This model is also very important. It is from permutation and combination. Prove that 25C4 plus sigma R equals to 0 to 4, 29 minus RC3 equals 30C4. So first let us take LHS. What is LHS? 25C4 plus sigma R equals to 0 to 4, 29 minus R C3. So that is 25C4 I am writing as it is. Now here I am applying the summation from 0 to 4. Summation means what? Keep substituting R is equal to 0, 1, 2, 3, 4 and you add all of them. So first I put R is equal to 0. So 29 minus 0 is 29. 29C3 plus. Now you put R is equal to 1. You get 28C3 plus. Now you put R is equal to 2. 29 minus 2 is 27C3. Now you put R is equal to 3. So you get 26 C3. And now at last you put R is equal to 4. So you get 25C3. Now I regroup. I regroup the first term and the last term. So because they both have 25 and 25. So 25C4 plus 25C3. I am putting them in a single bracket and the remaining terms I am writing in the reverse order so that I don't have to rearrange every time. So that is 26C3 plus 27C3 plus 28C3 plus 29C3. So because it is addition, order doesn't matter. Now over here in the first bracket, I use a formula. What is that formula? I am writing here at the right corner. So NCR plus NCR minus 1 equals to N plus 1 CR. This is the formula which we are going to apply here. So you can see in the place of N you have 25, in the place of R you have 4 and in the place of R minus 1 you have 3. So what will it become? it becomes 26C4 plus the remaining terms I write as it is. Now again I put the first two terms in a bracket and again I apply the same formula. What is that formula? NCR plus NCR minus 1 equals N plus 1CR. So that is 27C4 plus again I write the remaining terms as it is. So 28C3 plus 29C3. Now again the first two terms I put in a single bracket and again I apply the same formula. So we get 28C4 plus 28C3 plus 29C3. Again I put the first two terms in a single bracket. So we get 29C4 plus 29C3. Now finally this becomes 30C4. This is RHS. Take the next question. It is from partial fractions. Resolve the fraction into partial fractions. So let us take x square minus x plus 1 by x plus 1 into x minus 1 whole square equals to. Now you can see in the denominator you have two linear factors, but one factor has power 2. That means it has a repeated root. So whenever repeated root questions are given, let us see how to resolve them. So that is a by x plus 1 plus b by x minus 1 plus c by x minus 1 whole square. So how to take LCM over here? Taking LCM is a big task here. So x plus 1 into x plus x minus 1 whole square equals to, now what is the LCM? Don't multiply all the three factors. Just write the highest power. So x plus 1 into x minus 1 whole square. Now how do you write the numerator? Now in the first term denominator you have x plus 1. What is lacking from the LCM? X minus 1 whole square is not there in this term. So we multiply a with x minus 1 whole square plus b into. Now 1 x minus 1 is there. So what is not there from the LCM? We don't have x plus 1 and one more x minus 1 plus c into. Now you have x minus 1 whole square. So what you don't have from the LCM? You don't have x plus 1. So this is the way of taking LCM. Now we cancel the denominators. So we get x square minus x plus 1 equals to a into x minus 1 whole square plus b into x plus 1 into x minus 1 plus c into x plus 1. Now, how can I make x minus 1 as 0? If I put x is equal to 1, wherever you have x minus 1, that becomes 0. So on the left hand side, if we substitute x is equal to 1, we get 1 minus 1 plus 1 is equal to c into 1 plus 1. 1 minus 1 cancel, 1 equals to 2c. So that is c is equal to 1 by 2. Now what other substitution we can take? We can take x is equal to minus 1 so that x plus 1 will become 0. So wherever you have x plus 1, that will become 0. So minus 1 whole square is 1. Minus of minus 1 will become plus 1. Plus 1, that is equal to a into minus 1 whole square. So 3 equals to 4a. And so a becomes 3 by 4. Now we got a and c values. Now to find b value, we need to compare coefficients of x square. So on the left hand side, coefficient of x square is 1. And on the right hand side, if you expand this bracket, you get one x square term. What is the coefficient of that x square? It is a. And in the second term also, if you multiply these two terms, you get one x square. What is the coefficient of x square? That is b. So what is b? b is 1 minus a. So B is 1 minus 3 by 4. So you get B as 1 by 4. So you got B as 1 by 4. Now already we got A and C values. A is 3 by 4, C is 1 by 2. A is 3 by 4 and C is 1 by 2. Now let us see how to resolve it into partial fraction. So substitute A, B, C values in equation number 1. So let us take this step as equation number 1 and we substitute here. So x square minus x plus 1 by x plus 1 into x minus 1 whole square equals to 3 by 4 into x plus 1 plus 1 by 4 into x minus 1 plus 1 by 2 into x minus 1 whole square. This is how we resolve into partial fractions. Now take the next question. In a committee of 25 members, each member is proficient either in maths or stats or in both. If 19 of these are proficient in maths, 16 in stats, find the probability that a person selected from the committee is proficient in both. So let us say S be the sample space. So when a person is selected or a person is chosen at random, then N of S is equal to 25C1. That is 25. Let A be the event that the person chosen is proficient in maths. So N of A is 19C1. That is 19. Let B be an event that the person chosen is proficient in stats. So N of B is 16C1, that is 16. Okay, so if N of A is 19, so P of A is, what is P of A? P of A is N of A by N of S. That is 19 by 25. And over here, what is P of B? N of B by N of S. That is 16 by 25. Okay. So as you can see, everyone is proficient in any of the subject. Everyone is proficient either in maths or in stats or in both. That means P of A union B is equal to P of S. But from probability basic concepts, we know that probability of a sample space is always 1. So P of A union B is 1. Now we use addition theorem here. How can you write P of A union B? P of A plus P of B minus P of A intersection B is 1. Now P of A is 19 by 25. P of B is 16 by 25 minus P of A intersection B is, now 1 can I write 25 by 25? To make the simplification easier, I'm writing 1 as 25 by 25. Now I'm taking this P of A intersection B to the other side, 25 by 25 this side. So P of A intersection B is equal to 19 by 25 plus 16 by 25 minus 25 by 25. Add the numerators, 19 plus 16 minus 25 by 25. That is 35 minus 25 by 25. That is 10 by 25. 5 twos are 5 fives are. So the answer is 2 by 5. Now take the next question. This is also very important from probability. Suppose A and B are independent events with P of A is equal to 0.6 and P of B is equal to 0.7. Then compute number 1 P of A intersection B, number 2 P of A union B, number 3 P of B given A, number 4 P of A complement intersection B complement. So first let us write what is given to us. Given P of A is equal to 0.6, P of B is equal to 0.7. Now here one more thing is given, independent events. A and B are independent events. So since A and B are independent events, what is the condition we have for independent events? P of A intersection B is equal to P of A into P of B. So first we will take the first bit, P of A intersection B. P of A intersection B, as I just told you, we can write it as P of A into P of B. So P of A is 0.6 into 0.7. So that is 0.42. Just multiply 6 into 7 and before 2 digits you place a point. Now second bit, P of A union B. From addition theorem, we can write P of A union B as P of A plus P of B minus P of A intersection B. So P of A is 0.6 plus P of B is 0.7 minus P of A intersection B is 0.42. So 0.6 plus 0.7 is 1.3. 1.3 minus 0.42. Now I'll show you how to subtract 1.3 minus 0.42. In the blank area, you place a 0. So 0 becomes 10, 3 becomes 2. 10 minus 2 is 8. 12 minus 4 is 8. So this is 0.88. So the answer for the second bit is 0.88. Now we need to find P of B by A. P of B by A, whenever B by A is given, that means it is conditional probability. It is also read as P of B given A. So the formula for P of B by A is P of A intersection B by P of A. So just now I told you when they are independent events, you can write it as P of A into P of B by P of B. Sorry, by P of A. So we can cancel P of A, P of A. That is P of B. What is P of B given in the question? It is given as 0.7. So it is 0.7. Now number 4. What is the fourth bit we need to find out? P of A complement intersection B complement. So P of A complement intersection B complement can also be written as P of A union B whole complement. Now how can you write P of A union B whole complement? 1 minus P of A union B. That is 1 minus, what is P of A union B? We got 0.88. So this is 0.88. So what is 100 minus 88? It is 12. So 1 minus 0.88 will be 0.12. This is the final answer. Take the next question. It is from complex numbers. If z is equal to 3 minus 5i, then show that z cube minus 10z square plus 58z minus 136 is equal to 0. So first let us write what is given to us. Given z is equal to 3 minus 5i. First we will find z square. Z square is 3 minus 5i whole square. Now apply a minus b whole square formula. So a square is 9, b square is 25i square, minus 2ab is 30i. Now we will take I square as minus 1. So 9 minus 25 minus 30i. 9 minus 25 is minus 16 minus 30i. This is z square. Now how do you get z cube? Z cube is z square into z. So that is z square is minus 16 minus 30i into z is 3 minus 5i. Now multiply. How do we multiply this into this into this into this into this? So minus 48 plus 80i minus 90i plus 150i square. So that is minus 48 minus 10i minus 150. So that is minus 198 minus 10i. This is the value of z cube. Now we will take LHS. What is LHS? Z cube minus 10z square plus 58z minus 136. So that is equal to z cube is minus 198 minus 10i minus 10 into z square is minus 16 minus 30i plus 58 into what is z? 3 minus 5i minus 136. So that is minus 198 minus 10i plus 160 plus 300i plus what is 58 into 3? 174 minus what is 58 into 5? 290 minus 290i minus 136. Now you see what is 160 plus 174. 160 and 174 is 334. Now minus 136 and minus 198 is also minus 334. Now minus 10i minus 290 is minus 300. Minus 300 plus 300 get cancelled. So 334 minus 334 is 0. That is RHS. Therefore, you can write LHS is equal to RHS.